In this short lecture, I'm just going to go over the number 1 and how it has infinite values and what 1 really could mean, because it could essentially mean anything. When we talk about the number 1, we can go to Euclid's book. He wrote his Book of Elements, and here's a chapter of his Book of Elements, Euclid's Elements, and Book 7. Definition 1 is a unit is that by virtue of which each of the things that exist is called one. So that's one definition of the number 1 as a thing or an object. Then we can go into other definitions of 1 where we use Euler's identity. And if we look at Euler's identity, we can see that e to the I pi plus 1 equals 0. Or if we solve this for 1, it's 1 equals negative e to the I pi. And if we look at the Tau Manifesto written by Michael Hartle, we can also see that a different way of looking at that would be that e to the I tau equals 1, where he goes through the same identity. He solves e to the I pi equals negative 1, and then e to the I tau equals 1 plus 0, or e to the I tau equals 1. So here's another definition of 1. So that's an exponential definition. This is a definition in terms of sine. Sine of pi over 2 radians equals 1, or sine of 90 degrees equals 1, or 1 equals cosine 2 pi, or 1 equals tangent 45 degrees. Or in terms of imaginary numbers, well, any number raised to the power of 0 is also called 1. Or imaginary number is square root of negative 1. So negative 1, square root of negative 1 times square root of negative 1 is negative 1. And then that squared 2 more times brings you back to 1 again. So imaginary number to the 4th power equals 1. And then we have 1 as any item of unity. So 1 over 1 equals 1, or 2 over 2 equals 1, or pi over pi equals 1, or elephant over elephant equals 1. Of course, this can be infinite number of whatevers, 1 meaning unity. And then we have our definition, which is a mathematical trick, which I can go into sometime, but it really, this is kind of not really, it's more of an expansion trick that's used to say that 1 equals 0 factorial. But basically math has defined it like this, so we'll just leave it like that. Another definition of 1. And 1 equals, here's another thing, any power to the, any number to the power of 0 is 1. And again, this is like basically talking about the non-dual state, which if you go through my lecture on exponentials, you'll see that this to the 0 power is actually could be anything. Same with this, but math defines these as 1 as well. So look at all these definitions of 1 that we have. Many different definitions. Since 1 is basically a concept, and basically 1 is defined by whatever concept we're using to display in relationship to what we mean. Here's like a location kind of on a unit circle. This is like, a location of 1. If I make a graph here, Now we're talking about 1 as a location, and it's a point here where it's cosine 0 degrees or cosine 2 pi equals 1. Or this would be I to the 4th power, since this is considered each turn of 90 degrees is an I. So all these definitions of 1, infinite definitions of 1 based upon how we need to use it. And also the last thing I want to just convey is that 1 has a particle, a wave particle duality nature to it. Because when we use 1 in this kind of function here, this is not a static function, e to the I tau. This function pretty much rotates around this circle. If I were going to show it in motion, this is pretty much what's going on with this function here. It's rotating around. It's a dynamic entity. This exponential is going forward in time. And if you look at my video on Euler's identity explained, you'll see that it only equals particle 1 at when this is in the non-dual state or at time 0. For all other values, this becomes this wave. So when does this wave become 1? Well, it becomes 1 right now, and it becomes 1 right now. Only when it touches that 1 is it 1. All other values, it has a component of other value of an imaginary component or some other value. So this is the wave particle duality of the number 1, whereas 1 can be written in a dynamic fashion given by this, or this static definition where 1 is a thing, or where 1 is a fixed location on a number line. So we could see that there is a wave particle duality nature of the number 1. And when I do my next lecture on non-duality versus duality, we can see how this is going to come into play. And that's pretty much the concepts I wanted to display in this lecture. That the value of 1 is infinite. And it can mean many, many different things, as we see here in front of us. It can mean complete unity or the non-dual state. It can mean a waveform. It can mean a particle. It can mean a location on a line. It can mean relationships between angles at certain values and relationships in radians at certain values. It can mean all kinds of things. So 1 is very versatile. And thank you for your time.